All right, everybody. Welcome to Earth Systems. We are going to be looking at sources of energy for humanity today, and this will be leading into a discussion assignment that you'll be finishing on Canvas after you watch this video. So let's get right into it. Don't want to waste too much time. All right, so we are going to present this to you here. All right. All right. So I'm presenting to everybody. All right. So let's take a look at all of this. All right. Start at the beginning. Sources of energy for humanity. All right. So get rid of that. All right. Humanity uses a lot of energy. So food, electricity, transportation. We're going to focus on electrical power. Okay. Electrical power. If you want to get this into your notebooks, go ahead and pause the video. I will be uploading this slideshow to Canvas files as always. So you can find all this information here if you don't want to come back and watch this video and listen to my voice, which is understandable. So if we look at this here, this is the amount of energy, this graph, amount of energy in terawatts that is from each of these sources of energy up to 2005. This is an old graph. I don't really need you to understand or memorize this graph or anything. It's just kind of a representation of what we're using for our energy in the past 50 years or so. All right. So if we go forward here, we're going to talk about the basics of electrical generation. We've already talked about this in class. Turbines, how they work. They are large motors that spin. Generally, a magnet goes around a bundle of wire, creating electrical current, and then we have an electrical field. So if you don't understand how turbines work, come back to this, get a little bit of a refresher. That's how most electricity that we use today is produced. Almost all the electricity that we use today is produced using some sort of turbine, some sort of spinning something. There's one exception. We'll get to that at the end. Okay, so we're going to start off first here with turbines that are spun by gravitational force from water. All right, and this is hydroelectric. All right, giant turbines are turned by water as it flows out from behind a dam. So here, this is a really, really famous dam here. This is Hoover Dam. If you go along I-15 down to California, you'll pass right by this. Pretty cool place. A lot of water here. The turbines are housed here in these giant columns. And as the water flows out from behind this dam, it goes out really quickly, spins the turbine. So it's clean and reliable. We can release more water if we need more electricity. We can hold it back if we don't need as much. Problem is that it's got to be on a river or lake. Don't have a lot of geographic flexibility with this. It's got to have water near it. So that's one of the problems. A lot of positives, few negatives. Hydroelectric is pretty cool, okay, especially in mountainous regions like here in the western United States. Clean and reliable. All right, coal. Coal is burned to heat water that turns into steam. That steam turns the turbines. That's generally how we do it. We use a source of heat, and it generates steam, and that steam goes and turns the turbine. It is reliable. It can produce on demand, and it's cheap. I mean, coal's in a lot of places, so you don't need to go looking too hard for it. And we've developed this infrastructure, this whole system, since the late 1800s. We've been building coal-fired power plants and so forth, and we have the system pretty well down. There are a lot of problems with coal, however. It pollutes the air with toxic chemicals and soot, contributes to climate change, which is obviously a big issue, and it's dangerous to mine. People get the black lung, the mind collapses on them. It's not a good time. Okay. Coal has a lot of issues, and obviously, I'm not a huge fan of it because of the whole climate change problem, right? But there are a lot of people that are big fans of coal. I think that this is a discussion that we have to have. Is coal worth the risk? Is it worth the damage that we're inflicting on the planet? Is it worth the danger to people's lives? Right. So there's that. There's coal. All right. Pretty straightforward. You burn it, it generates heat. The heat boils the water. The steam goes and turns the turbine. All right. Generally pretty simple. Moving on, natural gas, very similar here. All right. But this is natural gas that comes out of the earth as a gas, right? So propane, the methane, these are different types of natural gas. They're just complex hydrocarbons, so it's a carbon with some hydrogen stuck on, and we burn it. Same process with coal as with coal. You just burn it, it boils the water, the steam turns the turbine. Again, it's reliable, it's cheap, it produces on demand, has the same problems as coal. It's a little bit cleaner than coal, just a touch, but still has a whole bunch of problems. The destructive mining, this one right here, this is called fracking. You can do some research on this later on your own if you'd like, but fracking is a process where, I should have paid attention to the time. Fracking is a process where water is pumped into the ground, and then they use that water to fracture the ground, and it releases some of this natural gas that's trapped in the layers of rock. So you can do some research on fracking, as well as, if we go back to coal, the dangerous mining practices. That's one of the options for the later assignment that you'll be doing. So natural gas and coal, pretty straightforward. Have a lot of pros. They're reliable, it's cheap, it produces on demand. If you need more electricity, you just burn more coal or natural gas and creates more steam, turns the turbine faster, produces more electricity. So we can, that's definitely a positive, but is it worth the climate change, the pollution, and so forth? All right. Nuclear. All right. Nuclear energy. Radioactive material creates heat. There we go. And produces steam. Same process, just using heat from nuclear reactions as opposed to burning chemicals like natural gas and coal. It is clean and can produce on demand, and it's safe. So it doesn't produce any carbon dioxide. It doesn't produce any pollutants that go into the air, like soot and so forth, that can make us cough. Couple of problems with nuclear. It's expensive. It takes a lot of money to build these. It's free once you build the plant, but building the plant is pricey. The ignorance of the public is another big problem. A lot of people hear nuclear and they automatically think, oh man, like Chernobyl, right? Chernobyl was a really, really famous nuclear power plant in the old Soviet Union. It blew up, was bad times. A lot of people died. But if you compare nuclear energy in terms of deaths to natural gas or coal, or really pretty much anything, it's quite a bit safer, actually. So it is quite safe, but people just don't think about it that way. We've heard all the news about Chernobyl, and there was a nuclear power plant in Japan called Fukushima that had some problems. So it's safe, but not a lot of people know that it's safe. So that's one of the big problems. And another problem is that it produces radioactive waste, and we have to be able to store it somewhere. A lot of people talk about radioactive waste like it's the worst thing ever. But these are also some of the same people that are big proponents of coal and natural gas. And I would much rather have the ability to take the waste from this from the energy that we produce and put it deep in the ground and store it, than pump it into the air. With coal and natural gas, all you're doing is just pumping the material, the byproducts that are super dangerous up into the air for everybody to breathe, right? And that's a problem. With nuclear, you have to store the byproducts, the dangerous products that come out of the nuclear process, but you can do that in a safe way. So I am actually a big fan of nuclear. That's just my opinion. If you want to do more research on that, you absolutely can. Geothermal. So now we get into what is called the renewable. There's the warning music. I'll let that play. Yeah. Okay. I should have taken into consideration the time. I apologize. All right. So geothermal uses the heat from the earth, right? That's literally what geothermal means. Come on. This music is really bothering me. All right. Oh, okay. And then the bell's going to ring in about 30 seconds. That's going to be fun. All right. So we use the heat from the earth to boil water. Same deal. Use heat, turn it into steam, turn the water into steam from the heat. That is, turn the turbines. All right. It's clean and reliable. It's limited in availability. Okay. You got to be by a hotspot or by a volcano, which really limits where you can be. All right. So geothermal is awesome. If you check out Iceland is super cool. They generate a lot of their electricity using geothermal. In fact, this image here is from Iceland. So pretty sweet. But again, there's only so many places that we can put these things in the world. All right, wind power. You all have seen these turbines before. Wind flows through the large fan blades, turn the turbine, the top of the windmill. It's clean, it's cheap, it's unreliable though. The wind doesn't blow everywhere all the time. So that's a problem. Wind turbines are cool. A lot of people complain that they're noisy. Whatever, man. I mean, if that's your big deal, I guess that's your deal. But I would much rather have a noisy way of generating clean energy that doesn't pollute the air than a way that might be quiet but pollutes the crap out of the air, right? Again, that's my opinion, but I really think that wind is a great way to generate electricity. It does have its problems, right? The wind doesn't blow everywhere all at once, but it is it definitely has its positives as well. All right, tidal. Now this is an interesting one. This is one that we haven't talked about in class before. Robbie boy, Robbie, yes, you're like one of two students in the building. Your time has expired today. Tidal energy, it's essentially using a windmill in the water. So it's like a wind turbine in the water. It's predictable. The tides always flow at the same schedule. Again, there's very limited use. There's geographic limitations because you have to be near the coast, and that generally means that you have to find a specific place, and there's some problems with maybe disrupting fish and migration and all that stuff. So there are some issues, but I think this is a super cool one. If you want to check it out, a lot of really interesting research being put into tidal energy. All right, concentrated solar. This one is where you've got these huge mirrors, right? This is a very, very large, I believe this is in Nevada. Very, very large array of mirrors, and they all point toward this central tower. And that central tower heats up a lot. They might have water in there, or they might have actually molten salt, but they use that heat to boil the water. And that heat can just be exchanged back and forth, back and forth. They boil the water goes and turns turbines, and that turbine generates electricity. So pretty sweet. It is very inefficient, meaning that you get a lot of solar energy hitting this area, but you can only get so much energy from the tower. Well, it's not very inefficient, but it is quite inefficient. It's relatively inexpensive and it's clean, which are positives, but again, it's unreliable, can be one of those, cons. So, all right, last one, solar panels. Solar energy hits special panels that have free electrons. These electrons are pushed through the wires by light from the sun. So I'm not going to explain, that's a very simplified version, but it's pretty cool. It's clean, it's free after you make the panels and install them. Problem is, again, the sun doesn't shine everywhere. And we need to be able to generate electricity for everybody. So there are some problems. Okay, so we talked about all of these: concentrated solar, geothermal, wind, natural gas, coal, hydroelectric. I want you to think about which one of these is the most interesting to you. What is maybe a problem that you think that needs to be solved? If you go back to solar, how can we solve the problem of intermittent energy from the sun? Or tidal, or geothermal, nuclear? How can we educate more people about nuclear power, right? So all of these things that we need to look through. Okay, I'm going to just quickly get to the end here. Now I want to explain the assignment for this week. Here's what you're going to do. You are going to pick a topic related to today's lecture. That could be one of the sources of energy. So you can pick hydroelectric or coal, natural gas, nuclear, solar panels, concentrated solar, geothermal, wind, whatever, or just pick something that's related to it, right? So I just have a couple examples here. These aren't the only things that you can choose. Nuclear power risks. What are really the risks to nuclear power? Is it safe? Is it not safe? What about the waste disposal? That kind of stuff. Fracking. How do we get natural gas? Is it safe? Is it dangerous? Mountaintop removal, which is a type of coal mining. What's up with that? How does that impact the ecosystem? Solar batteries. How do we store the battery or store the energy in batteries from solar power so that we can power the world even when the sun isn't shining at night? So pick one of these topics. If you need to pause the video and look at this, do that as well. Pick one of these topics, and then you will be moving forward with that topic in mind. You need to find a YouTube video about that topic. Try and find a video that's less than 10 minutes. All right. I don't want it really, really long. It needs to be appropriate, obviously, and on topic. All right. If it talks about solar energy for like 5 seconds, I wouldn't consider that to be on topic. You're going to watch that video. All right. Obviously, you might need to browse a little bit, peruse for just a moment to see if you can find something that you will enjoy. All right, so watch the video, and then after you watch the video, go to the Canvas discussion. The Canvas discussion, I believe, is called Energy or Electricity Canvas discussion. It is the assignment for this week. You are going to post in that discussion the topic of the video, a question for other students to discuss that the video discusses, so that they can watch your video and have a discussion about it later, and then a link to the video. So copy and paste a link to the video along with a question that other students can answer or discuss, and of course just a basic topic of the video synopsis. And then after you post your own, you need to go and find another student's post, watch their video, and then answer the prompt in their video, in their post. Okay, so go back and answer their prompt, participate in the discussion on that post. All right, so that's going to be the end of this slideshow. I'm going to post this slideshow again at a different time. So that is the plan for this week. That's the assignment. You need to find a video related to this topic. You need to make a post on the discussion and then post on someone else's post. All right, reply to someone else's post. Hopefully we can have a good discussion about this. I'll be in the discussion, hopefully not having to moderate too much, but participating. I think that there'll be plenty of interesting stuff. And of course, if you have questions, email me or send me a message in the Canvas application. All right. Thanks for checking it out. Let's go.